Hi, in this video we can see the next few problems in exercise 1.2. First we can take problem number 5. Check whether 6 power n can end with the digit 0 for any natural number n. This is the problem. So, exercise 1.2, problem number 5. Here we have to check whether 6 power n ends with 0. For this, for any number to end with 0, it should have factors 5 and 2. So, to end with 0. On considering 6 power n, this we can write as 3 into 2 power n. So here we have the factors 3 and 2. But factor 5 is absent. So, we can conclude that 6 power n cannot end with 0. This is our result. As 5 factor is absent, this is our result. Okay. Then we can proceed with the next problem. Problem number 6. Explain why 7 into 11 into 13 plus 13 and the other one are composite numbers. Here we can consider the first one and we can do this. 7 into 11 into 13. Problem number 6. 7 into 11 into 13 plus 13 is given. This is A and this is B. From A and B, we can take 13 as common. On taking 13 as common, 7 into 11 will be remaining in A and plus 1 will remain in B. So, again, this 13 we can have it like this. Here 7 into 11 is 77 plus 1. That is 13 into, this is 78. Here we have to factorize 78 and write its factors, prime factors of 78. We can check for the prime factors here. Being even number divided by 2, 3 2s are 6 and 1. So 18, 9. Then we can divide it by 3. So 1 3 is 3, 3 3s are 9. So the factors of 78 are 2 into 3 into 13. So this 78 we can end it up into its prime factors. So what we get is 13 into 2 into 3 into 13. This we can rearrange and write them as 2 into 3 into 13 into 13 or 2 into 3 into 13 square. So we can represent this form in its prime factors form. So this is a composite number. We can conclude it like this. Okay. Then we can move on to the next problem. There is a problem 7. There is a circular path around a sports field. So the path is circular. Sonia takes 18 minutes to drive one round in the of the field, while Ravi takes 12 minutes for the same, that is to make one round. Suppose they both start at the same point. So their starting point is the same and start at the same time and go in the same direction. So they move alike. Okay. After how many minutes will they meet again at the starting point? So after how many minutes will they meet? So they have to meet. Okay. So here after how many minutes? So that is nothing but the minimum time required for them to meet at the starting point. So that is least common time. That is nothing but least common factor. So we have to find the LCF between 18 and 12 so that we can arrive at the common meeting time. Okay, this we can work out. So solution, first one is 18, the other one is 12. So on dividing it by 2 we get 9, again 3 and 3. For 12 on dividing it by 2 we get 6, then we get 2 and again 3. So the factors of 18 are 2 into 3 into 3. The factors of 12 are 2 into 2 into 3. So here we have to find the LCF between 18 and 12. So LCF of 18 and 12 is, the common factors are 2 and 3 with its maximum power. So what's the maximum power of 2? It's 2. Maximum power of 3 is again 2. Here we have 3 2's. Here we have 2 3's and here we have 2 2's. Okay, 2 3's and 2 2's. So we can write it like this. So this is 4 and this is 9. Here 9 4's are 36. So 36 is the LCF. So after 36 minutes they will be meeting. Okay, this is the answer for this problem. Thank you. Have a nice time.